All right, today we're going to pull back the curtain on a Python feature that I promise will totally change how you write classes. It's going to make your code cleaner, shorter, and just way more powerful. Let's get into it. I mean, if you've ever written a class in Python, you know this feeling, right? You type out def underscore underscore init underscore underscore self, comma, blah, blah, blah. And then self.name equals name, self.age equals age. It's this ritual we all have to do. But let's be honest, it feels like a total chore. So, before we jump to the shiny new solution, let's really sit with the problem for a second. We're all familiar with it, the traditional, kind of clunky way of defining classes in Python. So, check out this standard student class. Yeah, it works. Of course it works. It definitely gets the job done. But just look at all that ceremony. We are literally just telling Python what it should already know, that the name argument goes into the self.name attribute. It's all this manual setup. And, the problems here, they go way deeper than just a little extra typing. You've got all this repeated code, which is just asking for bugs to creep in. And if you want to see if two student objects are actually the same, well, you have to write all that comparison logic yourself. Same deal if you want to print the object and see something useful. You're doing a ton of extra work just for the basics. So what if you could get all of that? The initialization, the pretty printing, the comparisons. What if you could get all of it without writing a single line of it yourself? What if Python just handled it for you? Well, guess what? It can. So let's meet the hero of our story today. It's a simple little decorator that does some seriously heavy lifting, the one and only @DataClass. So what on earth is a data class? Well, at its heart, it's just a regular class, but it's been optimized for storing data. When you tell Python, hey, this is a data class, it just automatically creates all those special methods we were just complaining about. Init, rep for printing, and equal for comparing things. Okay, and this is where the magic happens. Look at the difference. Compare this to that class we saw just a minute ago. We just slap that @DataClass decorator on top and then list our attributes with their types. And that's it. That whole double init method, all that self.name equals name business, poof, it's just gone. Python is generating all of that for us, right behind the scenes. Now, that might feel a little too much like magic, so let's actually unpack those superpowers and see them in action. This is where you're going to really start to love this. First up, printing. So we make an instance of our new student data class and we print it. With a normal class, you'd just get some weird cryptic memory address. But with a data class, would you look at that? A beautiful, clean, readable representation of the object and all its data. So useful for debugging. Okay, next up, comparison. Let's make two different student objects, S1 and S2, but with the exact same data. Now remember, these are two separate objects, living in different places in memory, but they represent the same student, right? So what do you think happens when we ask Python if S1 is equal to S2? Normally, without writing our own EQ method, this would come back false because it's just comparing memory addresses. But with our data class, and bam, true. The data class literally wrote the code for us to compare every single attribute. It just knows that because the name, age, and roll number are identical, these two objects should be considered equal. We got all of that for free. Okay, so right about now, you're probably thinking, this is cool for just data, but what if I need to add my own logic? And the answer is, absolutely. Yes, you can. A data class is still just a class. You can add your own methods, like this isPass method here, and they work exactly like you'd expect. You really get the best of both worlds. And hey, one more quick trick for you. Need a default value for an attribute? It's as easy as it looks. You just add it right in the definition. So now, if you create a student without giving them any marks, it'll just default to 0. So clean, so simple. Okay, you've totally got the basics down. Let's level up and look at a few advanced tricks and some important rules so you can really master using data classes in your projects. Now, this is one of my favorite tricks. You can make your objects totally read-only or frozen, as they call it, just by adding frozen equals true right inside the decorator. You're telling Python, hey, once this object is made, nobody can change its attributes. This is fantastic for code safety, especially when you're working with things that should be constants. And this table just lays it all out so clearly. With a normal class, you're doing manual labor every time, for initialization, for representation, for equality checks. With a data class, all of that is just automatic. And the real kicker is the bottom line. The impact on clean code is just massive. It's a huge improvement. So where should you actually be using these? Well, they are absolutely perfect for any time a class's main job is to just hold some data. Think about it, parsing data you get back from an API, holding all the configuration settings for a machine learning model, storing the current state of a game, or managing your application settings. All perfect use cases. But hey, let's be real, they're not a silver bullet. If your class is less about data and more about doing things, complex behaviors, or it's part of a deep inheritance chain, or it causes lots of side effects, a good old-fashioned traditional class is probably still your best bet. The key takeaway is this: data classes are for, well, data. All right, let's bring this all home. Why does learning something like data classes even matter? Well, it's about shifting from just writing code that works to really practicing your craft with intention, with elegance. The advantage here is just crystal clear. You're writing way less code, which means fewer bugs and way easier maintenance. You get all these essential methods for free, your code instantly becomes more readable, and you still have all the power of a regular class when you need it. So what does this mean for you right now, today? It means you can immediately start writing code that is more professional, more robust. You've just mastered a modern Python feature that I guarantee you will see all over high-quality code bases, which gives you the power to both understand them and contribute to them. So I'm going to leave you with a little homework. Go on, open up one of your projects right now. Find that one class that's just drowning in boilerplate init code. You know the one I'm talking about. That's your first target. Go and turn it into a data class. Thanks for tuning in.